Hey everybody, this is Larry, this is me going Q3 of the weekly contest 332, continuous subarrays. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one was the hardest problem on the contest for me. I don't think it's actually that hard, but I just had a mind blank during the contest, to be honest. And if you look at how I did it, during the live portion, you'll maybe see that, yeah. And the core part about there are a couple of observations. Some of it you probably would have seen if you have done a couple of enough Leetcode problems. Yeah. Let's start with taking a look at n, right? So n is 10 to the 5th. That means that you cannot do anything n squared for obvious reasons of it being too slow. So basically the idea is you have to figure out that for each number, figure out a way to do it in at most log n time, right? My eye. Yeah, and yeah, and basically, one way to kind of think about it is that instead of doing all continuous subarrays and kind of like, I don't know, do some looping scheme, the idea is that given a list of numbers, I don't know, I'm just going to repeat the list to make it look longer. For a list of numbers, just say, okay, how many continuous subarrays are there that ends at this number, right? That's basically it. For every number, say, okay, how many subarrays are there that ends at this number? And then now, to count of any subarrays, you know that to be continuous, it almost kind of like a prefix something, meaning that, if length 2 is good, or if length 4 is good, then length 3 is good, length 2 is good, and length 1 is good, and so forth, but not further, right? Necessarily. So that's basically the idea. I think during the contest, I got very confused about what I want from the problem. And I think now, a little bit afterwards, and maybe this is one of those things where if I had skipped ahead and came back and with a fresh mind, I probably could have gotten this very quickly, but I was sloppy. Yeah. So I'll show you the way that I did it, and then we'll go over a way for me to do it live together. Because I think I had, go by another way. So the way that I did it is with this concept called monocues. And monocues, monocues, kind of a, I have a whole tutorial on it. Definitely search for Larry monocues. I think that'll probably show up on YouTube. But the idea is that, it lets you, the idea is just about the invariance, and that's really the biggest part about the monocues. The monocues, the invariant is that it's monotonically increasing or monotonically decreasing depending on the max or the min property, but that is an emergent property of what you want, which is that the invariant of everything in the queue, is ordered in the input order, and that you're able to every operation kind of operates on on getting the max or the min, right? So I'll show the code very briefly. The max and the min are pretty much the same, except for, well, one is the max and one is the min. But basically when you add a new item, we look at the end, because basically the idea here is that, I don't have to think, is that, okay, greater is a max queue, meaning that it gives us a mono queue that allow us to get the max number over a range, right? And that's the greater one, just to be clear. And And just to kind of give an example, we have like, I don't know, 5, 6. I'm just banging on the keyboard, really. Right, and then the idea here is that, okay, for let's say, for 5, okay, the max element is 5. For 7, the max element is 7. But going to the 7, that what is the max prefix, right? Well, the max prefix, no matter what, is going to be, or maybe another way to say it is that 5 will never be the max again, because for the numbers that goes afterwards, if it's either 7 is the max or the new number is the max, but it'll never be 5, because by definition 7 is greater than 5, and that's basically the invariant that we try to uphold. And and this gives us the max over a sort of a window. So every time we enqueue the x, we enqueue on the max q and the smaller q, and basically we want to dequeue every time excuse me, any time the max number, if the max q contains a number bigger than x plus 2, so that we kind of start almost like a sliding window. We trim from the beginning, but instead of trimming by the first element, we trim by the max element of the mono q. So that we keep on doing until the max gets small enough such that it gives us the window. And the same thing is that we do that for the min side, of course, and then we just count the number of items in the queue, because that's the number of items that are that's the length of the thing, right? Because that's how we construct it. And you choose the min because obviously you take the shorter one, because that means that the shorter one is the tougher constraints. So anyway, so how would I do it now that I kind of understood a little bit better? I mean, I'm still within contest time, but I'm like about 20 minutes later. So let's rewrite this. I think sorted containers is probably a good place. Import sorted containers, right? So then here we would maybe have a sorted list instead of doing a mono queue if you didn't have understanding of it. Then here we just add x smaller. We just add x as well, and then basically it's the same idea, which is that while length of greater is greater than 0, and the get max is just the biggest item, right? Same for smaller. If the smallest item is there, then we I think we have to keep track of the left on here. Right. So then now we dequeue by removing the greater left item. Something like this. Greater dot remove. Smaller dot remove. Nums dot smaller left. Of course, you have to increment. And I think that is basically the same code. Well, okay. Is it from sorted contain? Oh, sorted list. Yeah, and if I had kind of, because I knew what I think, to be honest, I felt this one a little bit, but I didn't really understood it, right? So, and that kind of took, and I kind of got stuck on a mono. So if you look at how I did it during the contest, I got stuck on a mono stack kind of thing, and then I just couldn't figure out my way out of it. But I think if I was really thinking, if I kind of book it, because I was trying to solve the problem in one thing, but I think if I just book it down into 2 components, then that would be basically, this is how I would solve it. The 2 component is, one, being able to get a sort of a windowed max and min, and then only removed from that window if certain condition happen. And I was trying to, I think in my head I got confused about doing both of them in one operation type thing, and I kind of got confused. But yeah, the way that you do it with sorted lists, the add and the remove is going to be log n, so this is going to be n log n. But if you look at the mono Q version, it's going to be O of n, so that's going to be a little bit, well, it's definitely more performant, though I am curious whether, so yeah, so definitely the mono Q version is faster, but you know, I think if I could do it again, I would do this during the contest because it would be so much faster to code. Yeah, just a lot of silliness. Anyway, that's all I have for this one. Let me know what you think, and you could watch me start it live during the contest now. Wow, I am. This is one of those days. It happens. Number of continuous subarray. What's a subarray? For every pair. It's pretty straightforward, but I'm a little bit slow today, so maybe not. Let me think about this. Let me not rush this. I've been a lot of silly mistakes on the rushing. Huh. Wow, man, I'm really off today, am I? Did I miss a thing or something? Oh, did I do the math wrong? It's not this. No, it should be right. Am I off by one? Degree of freedom? No. Why is this 55? Oh, I'm returning 55. So I'm overcounting. Huh. I misread that actually. I'm just very sloppy today, I think. But still, one. That is clearly wrong. Oh, I am wrong. Whoops. Huh. So it's not just sliding window, but because this can go over 64 even though it doesn't pop the beginning ones. Okay. So I'm very. I thought I. Yeah. Okay. I mean, I. Last instance. I want to sort of this. Oh man, I really messed up this one. Okay, so. Oh, I'm really sloppy today. Basically, did I paste this? Yeah, okay. Basically, what I want is to what I want isn't this necessarily, though that could work. But what we want is greater and is smaller than anything. So how I do it, I don't even know anymore. And then we create that. Okay, and then now we take the greater index. Okay. Well, that's just the greatest number, right? But then now, am I doing this right? Let me search again. Wow, I totally misunderstood this one, I think. But, okay. Okay, so then we want to search for. Okay, I think I got it. Maybe I don't need all this stuff. Okay, and now we'll do binary search. This is great, and we want. Yeah, like 43 is the answer. 40. It's a little bit off. Let's see. Six. 1, 2, 3, 4, 5, 6. I do this one. If the query number is greater than. Did I do this wrong? No, I did it wrong. Oh man, I did it the other way. I need the suffix going this way, not the other way. Okay, because I know this is over 67, so that's why it was all bad. What am I doing with this problem? Wow, today is just my struggle day. Because basically 67, I think my original thing kind of makes sense. But okay, I think I did it the other wrong way again. It is what it is, just one of those days. Okay. This is a. I think I got confused myself. Oh my. otherwise it's smaller. Oh, okay. And then now we binary search on this one. Yes, okay. And then now we do a binary search on this one because it's yeah, okay. Still a bisect though. Is there a bisect with a key? I don't remember. Okay. Whoops, that's what I meant to do with it. Hopefully this is right. I don't remember if this is right. No, we want to reverse this, right? Oh man, this is so confusing. And then now this one is feeling bigger. So many mistakes to be made here too. Oh, it is a tuple, that's right. Yeah, well, still wrong, but maybe it's a little bit less wrong. 5G index. This is like really weird. Maybe that's why. So the smaller one should at least do something. Like. Okay, that at least does something. 2. And we don't want this, we want actually this. That's fair. Oh, jeez. Am I at least? Oh man. New York here, no bueno for me. Okay. Left, maybe I might be missing things. Still very well. We're searching for negative. This is true that there's nothing bigger. So why is it giving me the wrong answer anyway? That is 0, why? Greater does nothing, less. Smaller should be right though, right? Smaller is 1 index. So much debugging. Yeah, so then, and then index is 0. No, search for 1, right? So that should be smaller S index. Nope, this isn't right. I think this is good. And also using the wrong thing. Just noticed that. Okay. At least this is now trending in the right direction, maybe. This is 6, which is 1. Yeah, maybe that's right. I don't know. Definitely not right for the other ones though. Like this one. It's 5, 6, 31, so 5. The smaller one, the smaller thing works, I think, but the greater thing, definitely not. 4, nope. 2, nope. This is clearly wrong. Do I binary search decreasing series? Maybe I should just put it from the beginning. Also, this is wrong, but now this is right. And then now I can just do regular binary search, maybe. But still the wrong answer. That is this. This is the -1 now. So that's 1, that's right. 4 is 2, that's right. This is 3. No, that's not right. This is wrong already. The bicycle left 4 bicycle doesn't matter on this one. -1, yeah. Why am I struggling so much on this? I know how to do it, but oh, this is I and this is left. Might have so much numbers. 4 is 1 is wrong, right? Left is 1, y is left 1. Oh, because smaller. I want to do this before or afterwards. Maybe afterwards. Maybe that helps. Helps a little bit, but maybe I'm still wrong. 2, this is 2. This should not be 2. There's just something else fundamentally wrong. I'm just really bad today. Smaller index thing is a little bit weird. Because if we go through all of these, then yeah. But then it just means nothing, right? So it's hard to read actually. Okay, 0, 0, that's 1, okay, fine. 0. So, oh, am I doing binary search wrong? Because basically now we have an increasing sequence. So then now we want to do this, and now we want to do a minus one thing, yes. Okay, this is now still wrong, but maybe slightly better. 4. This is returning 9. This one's 2, this one's 2, this one's 3, but it's returning 4. Why is this? Oh. Still wrong. Oh man, maybe I'm just not understanding the problem. This is still wrong because the 4 is good with the 5, but the 2 is not. So the 2 would have to pop off the 5, right? I just don't understand this problem. I thought I did, but I am just getting decimated today. Well, lost that case. That's actually kind of sad. What am I getting confused about? I think I get it, but I think I've been just playing with similar but silly ideas with this thing. What I need to do is okay, yeah. What am I doing? I think the other way around, Larry. Okay, fine. Yes, but okay, that's not enough. What we want is the what do we call it? The monocue, right? I'm getting confused with all these mono things. Okay, that's definitely true. So rusty with the monocue. And I wrote a tutorial on it. Okay, so what is true? Pop it. I don't know what the answer is, but I don't think that's right though. What is the case that I got? I don't even know anymore. That's not quite enough, I don't think, but oh, that's why. This should be the case. Okay, fine. 10, right? So that's 1, 2, 3, 4. So that's not right. Okay. It's not this thing. It's well.
Hey everybody, this is
I'm trying to look at my MinoQ code. I don't remember it, to be honest. Maybe I should have just copied it instead of trying to think about it from first principles.
off.
What am I doing? Maybe I should have just used the queue. I mean the template. It's this absolute monster that previous Larry was doing. Okay, let's do the min heap first. That's the part I was missing. So in Q we do pop. Right, okay. Something like this, right? Okay. How do I want to do it? And the max scale is just the same except for I am a mess today. Ain't I? Yeah, I try to rush everything too much. So basically, we want. I don't think my API is very good, but still wrong though. 1, 2, just. Oh, it should be smaller. Whoops. Maybe I should have just done that from the start. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this this problem, this contest, and everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.